Okay, so just wanted to do a quick little screencast here. It's kind of end of the day on a Friday. Thought it would be interesting to share some additional updates. Um, I'll link to a previous screencast if you haven't seen it, but this is sort of an area where we have kind of our, fitting our stuff into the PMO process of business impacting projects and technology projects and different phases of those projects and the work that we're doing. In a previous screencast, we showed off some of the user flows for this specific project. But wanted to point out that we're, want to be intentional about making sure that we're not overlooking other functional areas impacted by just building out part of the product. So we've done that in terms of the user flows and want to show off a few other things here. So I want to start with the build and deployment engineering as well as QA really quickly up front. And to do that, we'll show off, and this is great now that this is in the California Data Center, you can see that it'll be accessible by anybody at ECD. It's just Jenkins. It's our sort of dashboard for all of our environments. You can see that there's dev and QA environments across a series of products for SafetyWeb, for MyID, our core platform as APIs. It's not tied to either of those products. We call it an internal abbreviation for IAE, for Identity Analytics Engine. And these are scheduled to have different times of builds, automation of automated tests run every day. From a QA perspective, once we start to integrate with Jim's team and have those types of things, you can come into any specific environment just with a click of a button. You'll kick off a build. I won't do it now because it'll sort of slow down the environment a little bit, but you can just fire it up and get the latest code and database refresh and all those different types of things. The other thing to point out, sort of going back from moving on from build and deployment engineering. Oh, and one last thing from a deployment engineer's perspective, you can sort of obviously click into any build over time, and it keeps a history so you can see how well the build's progressing in terms of failed builds, successful builds, what's causing it to fail, different things like that. And then jumping on to engineering kind of as the user, the functional area to make sure that engineering is not being overlooked. We have our code automation, so this also ties into QA as well. But interesting to point out, it's good in terms of our process, which mirrors very similarly the rest of engineering. Is we have our tasks, our work orders, or production support tickets. We define what those requirements are and work through it. And make sure that just making sure it functions isn't the end of it. We want to go through and have test automation for QA. We want to sort of have peer review for our code, and that peer review happens at different layers. So there's a certain amount of automation, but also individual interaction at the end. And automated tests are a great way to do that. So you can sort of see with this visualization, we're actually clicking through classes in our code base. And what it's telling us is the green and the red are lines of the code that are actually executed by all of our tests. And these tests happen after every commit to the code base, multiple times a day. And that way we always know that the code's in a good state, and if it ever breaks, the team sort of swarms and helps fix the build to make sure that it's in a known good state. So. But this does help point out as a team, as we review this, certain conditions that we haven't passed in the appropriate data or set up the right mock objects to force a specific test case. And this is why working with a full QA team and Jim's team is valuable, because there's always that balance of how much testing is overkill, diminishing returns versus, hey, this class we can tell by a quick visual and digging in that we didn't get enough, so we need more automation to make sure we cover ourselves. And the other point is, if bugs pop up, we make sure that we write a test for it first, fix it, and then that test will always remain so that that bug never gets reintroduced to the code base, which is a great practice and helps a lot. Other sort of metrics from an engineering perspective, we have our, and these again, I'm going to take a step back, as part of our definition of done, which is every cycle that we go through and build stuff and release it. In each work order or production support ticket, we have our definition of done, and that's what level of automated tests do we want, what are the business acceptance criteria, internal and external documentation that may or may not be created, and external docs could be things like external, looking API docs for other business units or end consumers, marketing tour pages that need updated because we changed a feature, so now the marketing page needs updated to reflect the feature, etc. And then we also have internal documentation, which we put in every ticket that we do, because we want to make sure that it compounds and builds on itself. And types of internal documentation are having systems like this for code coverage reports, being able to dig into the builds, Java docs on our Java stuff, setup documents, so as a new hire onboards, they can have their first day lined out for going through, getting their environment set up, exploring the code, logging in, getting their first, low-hanging fruit ticket, getting it fixed, and actually contributing on their first day. Different things like that. So those are part of our internal docs. And another part of the internal docs, which again is automated and kind of goes to that flow of, okay, I've built my code, it needs to be peer reviewed before it goes out. We try to automate as much of that as possible. Part of that is done with these tests, which are actually testing the functionality. But there's other types of automation that can happen around that, and I'll click into this project. It's set up specifically to check out the code and run all of this analysis and introspection on not as the product or functionality working as it is, but actually inspecting the code base itself. And you can see how this stuff sort of trends over time. We actually saw this and did a big refactoring to make some improvements here, which is kind of interesting. And I'll just pick a few of them to show off really quickly. So it's looking at our code and looking at common patterns. There's big repositories from, it's just shared patterns. It doesn't matter whether it's C# or Java or PHP or et cetera. It's common bad coding patterns that it knows to look out for and alert you to if it sees it. So we're as guilty as anybody. If we look in, we have 7 high priority, 46 normal priority. We'll jump into the kind of glaring errors first and take a look. So if we go in, we can see that there's an internationalization thing that we're not approaching correctly, which is a high priority. A malicious code, which is a little less high priority, and literally what it's calling out, you can see right here, is that in this package, in this class, the finalize method should be protected, but we defined it as public. So it may not mean a lot to everybody, but it's good to have that stuff automated and surfaced to you as a team so that you can go in and stay on top of that in real time, so that it doesn't compound over time, so that you can stay on top of it. I imagine that we'll start to set thresholds as well, so that these types of things, if they hit a certain threshold, will break our build, just like our automated tests, which actually test the functionality of the product, break the build. So lots of different automated things that it inspects on the code. Here's another one of duplicate code. So we go in, over time, copying and pasting code everywhere is a sign of poor design, of not reuse. So it calls those things out, so you can sort of refactor over time and improve your code base. And just a lot of different things like that, which is great. And then that said, obviously you want to automate as much of that as possible, which this does. It builds it multiple times a day, inspecting the code, and then at the end, still peer review the code base to get there.